Good morning, everyone. My name is Ying, and my Matric number is 24004616. Today, I will present an AI-based veterinary expert system for sustainable livestock farming in Malaysia. As we know, Malaysian veterinary sector is facing increasing challenges such as climate change, animal diseases, and shortages of veterinary experts. Therefore, AI and expert system can play an important role in improving livestock health and supporting better decision making. Malaysia's veterinary sector faces several major challenges. Climate change and heat stress can negatively affect animal health and productivity. At the same time, zoonotic diseases such as foot and mouth disease and avian influenza continue to threaten livestock farms. There is also a shortage of skilled veterinarians, especially in rural areas. As a result, delayed disease detection often leads to higher mortality rates and economic losses for farmers. Artificial intelligence can help farmers manage livestock more effectively. AI can analyze animal behavior, body temperature, and feeding patterns to detect diseases at an early stage. IoT sensors can continuously monitor animal health and environmental conditions in real time. In addition, predictive analytics can identify future risks such as disease outbreaks and heat stress. By transforming animal data into useful knowledge, AI helps farmers make faster and more accurate decisions. From a knowledge management perspective, knowledge is created through several stages. Data is collected from veterinarians, farm records, research databases, and disease reports. This data is processed into information and then organized into useful knowledge. Finally, the knowledge supports decision making by helping farmers and veterinarians choose appropriate actions. This process shows how AI and knowledge management work together to improve livestock management. The proposed veterinary expert system consists of three main components: the knowledge-based store veterinary knowledge, such as symptoms, diseases, and treatment methods. The inference engine uses if-then groups to analyze information and generate recommendations. For example, if an animal shows fever, excessive salivation, and mouth lesions, the system may suggest a possible foot and mouth disease infections. The system can then recommend actions such as isolating the animal and contacting a veterinarian. The proposed system provides several important benefits. Economically, it reduces mortality rates, treatment costs, and productivity losses. Environmentally, it promotes sustainable farming practices and reduces unnecessary antibiotic use. Socially, it helps farmers access expert knowledge even in remote areas. For example, AI monitoring system can detect diseases earlier, allowing farmers to take actions before conditions become severe. The development of this system follows the knowledge management system life cycle. The process begins by evaluating the existing infrastructure and forming a KM team. Next, expert knowledge is captured and organized into knowledge base. The system is then designed, tested, and implemented. After implementation, change management and continuously evaluations are carried out to ensure the system remains effective and up to date. Among all phases, I consider knowledge capture to be the most critical. This phase involves collecting knowledge and experience from veterinarians and animal health experts. It also converts tacit knowledge into explicit knowledge that can be stored in the system. If the captured knowledge is inaccurate or incomplete, the system may provide incorrect recommendations. Therefore, knowledge capture forms the foundation of the entire expert system. In conclusion, AI and expert systems can significantly improve livestock health management in Malaysia. They support disease detection, smart monitoring, and decision making. Knowledge management helps capture and share veterinary expertise effectively. Among all phases of the life cycle, knowledge capture is the most important because it directly affects the quality and reliability of the system. These are the references. Thank you for your attention.